Welcome to another session of Maths Fanatics 24/7. In this question, we're going to be looking at number patterns. Okay, so without wasting time, let's get to it. They say consider the pattern 5, 28 over 5, 31 over 5, then 34 over 5, and so on, right? And then before I even start, I'm going to firstly look at what type of a pattern it is. Né? So I always ask myself these questions in this order. Is it linear? So I always test linear, then quadratic, then geometric. Né? So I'm going to test if it's linear. Remember, if it's linear, the first difference must be constant. If it's geometric, if it's quadratic, the second difference must be the same. If it's geometric, T2 divided by T1 must be the same as T3 over T2. Right. Perfect. So now we're going to, let me just erase here to create space. So I'm going to check if it's linear now, okay? So to check linear, I have to subtract them. Né? This minus that, minus, right, sharp. So I'm going to just take my calculator and check né? Quickly. So we need to restart this quickly. Okay, perfect. So remember it's T2 minus T1. So which is 28 over 5 minus T1, which is 5. So I get 3 over 5, right? Now I'm going to do this one and that one. Awesome. Let's check now. So that one must be 31 over 5 minus 28 over 5, T3 minus T2. Let's see. And okay, let's just, I wanted to do a shortcut there. It's not working. So we'll just do it straight. Minus 28 over 5. This still gives me the same answer as this one, 3 over 5. Right. And then I can conclude that this is linear because I can see that the difference is constant. Right? The first difference is constant in this case. So here I can conclude that this will be 3 over 5. Perfect. So now I know that therefore this is linear, right? Perfect. Why? Because first constant difference. This is the symbol for because, né? That is for therefore. Okay. Awesome. Constant difference. Perfect. So now I know that is linear, then I'll just write this formula down somewhere because I know I'm going to use it, right? The formula for the nth term of linear pattern. Okay. Perfect. So now, actually, let's do this, ladies and gents. Let's do this. I'll just write this when we need it to create space to work out for now. Awesome. So the first question, they want us to find the next two terms. So they want us to find this term and that term, right? But I know that this term, if I add 3 over 5, is going to give me that term. Then that term, if I add 3 over 5, is going to give me this term, right? So I'm going to quickly do that on my calculator. So I know that if I add 31 over 5 with 3 over 5, I'm going to get this term here, right? Which is, 31 over 5 plus 3 over 5 gives us that one. So I still need to add again. The answer plus 3 over 5. That gives us 37 over 5. So this is 37 over 5, right? Awesome. And then now here, I'm going to add another one, right? to the answer. So this gives me 8. Ne? This gives me 8. Perfect. So we found the next two terms. We sorted. Now they say the formula for the nth term. Sometimes they say the formula for the Tn or the general term, ne? Or the value of the term in n position. Okay, the value of the term in n position. So remember I said Tn equals to A plus D n minus 1. This is the formula for the nth term. Ne? A is the first term, so A goes with 5. Therefore, Tn equals to 5 plus the number that you are adding all the time is your difference. Ne? So in this case, we're adding 3 over 5. Then we have n minus 1, right? And then we have Tn equals to 5. This bracket, we always need to FOIL. Ne? This multiplied by that multiplied by that. Remember here, there's an invisible one. So 5 over 3 times 1 is still 5 over 3n, right? Perfect. And then this multiplied by negative 1 is negative 3 over 5. I said 5 over 3 is 3 over 5. I'm sorry about that. It's 3 over 5. Awesome. And then Tn equals to, these two numbers are like terms. So I have 3 over 5n, right? Then I can see this gives me 25. So if you press this plus that on a calculator, it should give you 22 over 5. Then that's the formula for Tn, right? So Tn equals to 3 over 5n plus 22 over 5. Awesome. Okay, let's create more space. Awesome. Okay. Now we can go to the next question. So in the next question, they want us to find the 58th term. Ne? So let's discuss this again. The Tn is the value, ne? And then n is the position. So on this formula, you have two unknowns. You don't know the value, you don't know the position. But on question papers, they'll always give you one of this and ask you to find the other. So they'll give you the value and ask you to find the position. Or they'll give you the position and ask you to find the value. Okay, so in this case, I can see that this is the position. How did I know that is the position? So the position will always see it with fourth, third, first, 21st. Does make sense? So here I'm given n, I'm given the position. So I'm asked to find the value basically. So I'm asked to find the value of term 58, which is equals to 3, where there's n, I'm going to substitute 58 over 5 plus 22 over 5. And ladies and gents, if you press a calculator, that should give you 196 over 5. Right. Then we're fine with that one. Awesome. Okay. So now let's check this one. Which term will be equal to? Is this the position or is the value? This is the Tn. They gave us the value. Now they need the position of the term. So they're looking for n. Yeah. Awesome. So in this case, I'm going to take this and substitute there on Tn. So I'm going to have 397 over 5 is equals to 3n over 5 plus 22 over 5, right? Then obviously this part must go that side. So I have 397 over 5 minus 22 over 5 equals to 3n over 5, right? Awesome. And then we're going to have, let's check on a calculator how much we're going to get. So we have 397 over 5 minus 22 over 5. That gives us 75, right? So I have 75 equals to 3n over 5, right? But I need the n to be alone, basically, right? I need the n to be isolated. So the n is there. So this side I have 75, right? I'll show you something now. So whatever the number is doing to the n, this side is going to do the opposite that side. For example, the 5 is dividing relative to the n, you see? So this side is going to multiply. The 3 is multiplying the n, so this side is going to divide. So it does the opposite of what it does this side. Then if you press that on a calculator, it should give you n equals to 125. Right. That's the position. So term number 125 will be 397 over 5. Awesome. Then let's go to the last question now. Let's go to the last question. So I'll just leave this Tn. Okay, let's erase everything to create space. Sure. So my Tn was 3n over 5 plus 22 over 5, right? Then let's read the last question. So on the last question, they say, will this be part of the pattern, right? But this is Tn, you agree? Is not there. It's not the position, it's the value. So we're going to substitute it here. So I'm going to substitute it there for now, and then I'm going to explain what we're trying to get. Plus 2 over 25. So ladies and gentlemen, before we solve this, let's quickly explain. So to prove that the value forms part of the pattern, you always trying to show that n is a natural number. N is a natural number. Okay, by natural number, I mean 1, 2, 3, 4, 5, 6, and so on. So you are trying to show that n is not decimal, basically. So this can be decimal, and it can be negative, not 0, not negative. Perfect. So it just have to be a positive integer that is bigger than 0. Okay, perfect. A natural number. Sharp. So let's solve now. So obviously we're going to have 922 over 5. This must come this side to minus. So we're going to have minus 22 over 5, which gives us 3n over 5. Right. And then let's press a calculator and see how much we're going to get here. So we're going to get, let's see. So I have 922 over 5 minus 22 over 5, right? Over 5, which is 180, okay? So I have 180 equals to 3n over 5. Remember to isolate, I showed you what to do. So you write 180, and then this side you're just gonna be left with n. And then the 3 is multiplying with the n, so this side is going to divide, right? The 5 is dividing the n, so you're gonna say n divided by 5. Do you get it? So this side you must multiply. You do the opposite of what it does. And then if you press a calculator, n must give you 300, right? N must be 300. Then you're going to say, therefore, 922 over 5 is part of the pattern. Why? Because n equals to 300 elements of natural numbers. I mean, natural numbers is just elements of n, natural numbers. They usually show 2 lines there like that. And then that should be it about this question. So here, if you got a decimal number, you're going to say, therefore, this is not part of the pattern. Why? Because we're getting a decimal number, not a natural number. So ladies and gentlemen, if you haven't hit the subscription button, please do so. And don't forget to share with family and friends. See you soon. Aluta continua. Tango.